In today's industrial sector, efficiency and operational continuity are fundamental pillars. However, we often face a frustrating paradox. We have the technical knowledge to prevent a breakdown, but lack the real-time awareness to apply it. This disconnect between knowledge and the moment of action is a persistent challenge. Let's imagine your maintenance team knows exactly how to prevent a critical engine from failing. They know the signs, procedures, and solutions. But what good is that knowledge if no one is actively monitoring sensor data that would indicate the onset of a problem? The direct consequence of this lack of real-time monitoring is that important sensor data goes unnoticed. An anomalous vibration, a subtle increase in temperature, or a drop in pressure can be the first warning signs. If these signals are not detected and interpreted in a timely manner, the problem inevitably escalates, leading to late detection and, ultimately, operational failure. Knowledge, in and of itself, is a powerful tool, but its true potential is only unleashed when it is intrinsically connected to the operational reality of the plant and can be activated in a timely manner. It's not enough to know what to do. It's crucial to know when and why to do it, with the precision that only real-time data can provide. Consider a sensor that detects a critical anomaly. The information is there, but no one sees it, no one processes it. The result is predictable. The production line stops, generating significant losses and affecting the company's reputation. This scenario underscores the urgency of transforming static knowledge into dynamic action. Modern plants are complex ecosystems, packed with interconnected assets and equipped with a vast network of sensors. Every machine, every process, generates a constant stream of data. This abundance of information is great news, as long as we know how to capture, process, and most importantly, use it effectively. This data, if used correctly, is a goldmine for optimization and prevention. It's not just numbers, it's the pulse of your operation, revealing the health of your equipment and the efficiency of your processes. The key lies in transforming this volume of data into actionable intelligence. There are various sources of operational data, each providing a unique perspective on plant health. The Internet of Things, or IoT, provides us with detailed measurements such as temperature, vibration, pressure, and humidity directly from assets. This data is critical for condition monitoring. SCADA systems, for their part, provide a comprehensive view of system status, manage alarms, and store historical process data. They are the brains of the operation, centralizing control and monitoring. Their ability to record events is vital for retrospective analysis. CMMS, Computerized Maintenance Management System. Systems record interventions, breakdowns, and response times. They are essential for understanding each asset's maintenance history and optimizing task scheduling. They provide context for past actions. Finally, PLCs, or programmable logic controllers, manage the control variables, set points, and operational logic of the machinery. They are responsible for automation at the field level, executing the instructions that keep processes running. Their information is critical for precise control. The fundamental purpose of all these data points is to indicate the actual current status of your plant. They are the indicators that let you know if everything is working as planned or if there are deviations that require attention. Each reading, each event, is a piece of the puzzle that describes operational health. However, simply collecting data isn't enough. For this data to be transformed into useful and effective decisions, it's absolutely essential to connect it with your team's technical knowledge and experience. It's the fusion of data and know-how that truly generates value and enables proactive management. In the past, data sheets were static documents, repositories of valuable but passive information. Today, technology allows us to transform these sheets into living documents, capable of dynamically responding to real-time events in the plant. This evolution represents a paradigm shift in knowledge management. This transformation means that data sheets can cease to be mere references and become active aids in operational decision-making. They are no longer just a manual. They are an interactive guide that activates precisely when most needed, offering context and solutions at just the right moment. Let's consider a practical example to illustrate this concept. A vibration sensor installed in a critical engine detects an anomaly that exceeds preset thresholds. This detection is the first sign of a potential problem, an early warning that should not be ignored. Immediately, the SCADA system, upon receiving this signal from the sensor, issues a clear and concise alarm. High vibration. This alarm isn't just a warning, it's a trigger for action, an indication that something requires immediate attention. The information has been transferred from the sensor to the monitoring system. At this point, the magic of smart spec sheets truly comes to fruition. The specific spec sheet for the engine in question is automatically activated. No need to search for it. The system presents it proactively, directly linked to the event that triggered it. The content of this smart sheet goes beyond the technical specifications. It explains common causes of abnormal vibration, such as possible shaft misalignment or imbalance. It also suggests a series of pre-disassembly checks, optimizing diagnostic time. It can even link to instructional videos or detailed troubleshooting procedures. What was once a simple vibration alert is now transformed into a precise and explained operational recommendation. The system not only tells you that there's a problem, but also offers an initial diagnosis, possible causes, and steps to resolve it. This is the power of data contextualization. This approach converts raw information into actionable intelligence. The smart card not only provides data, but also interprets it in the context of the current situation, guiding the operator or technician toward the most efficient solution. It's knowledge activated at the right time and place. This is where artificial intelligence, or AI, comes into play, elevating responsiveness and proactivity to a new level. AI doesn't just process data, it interprets it, learns from it, and suggests intelligent actions. It's the brain behind contextualization and recommendations. The capabilities of AI in this context are transformative. It can interpret data in real time from multiple sources, simultaneously consulting structured data sheets. Its ability to suggest actions based on this knowledge and learn from each new case is what makes it invaluable. The AI workflow in this system is methodical and efficient. First, a sensor sends continuous data about an asset's status. This data is the raw material for analysis, the constant stream of information that feeds the system. The AI then analyzes this data in real time, comparing it to critical thresholds and pre-established patterns. It not only looks for out-of-range values, but also for trends and correlations that could indicate an emerging problem. Its processing capacity is instantaneous. If an anomaly is detected, the AI searches through the smart data sheets related to the asset and the type of problem. It accesses the structured knowledge base, identifying relevant procedures, causes, and solutions. It's like having an expert consulting thousands of manuals in seconds. Based on this information, the AI generates immediate and specific recommendations for the operator or technician. These recommendations are not generic. They are tailored to the exact situation, offering the most likely and efficient steps to resolve the problem. The guidance is precise and actionable. Finally, the AI records the effectiveness of the actions taken and learns from each new case. This continuous feedback loop improves its diagnostic and recommendation capabilities over time. Each successful or unsuccessful intervention refines its knowledge model. Let's consider a practical example of AI intervention. If a pump's pressure drops below 2.5 bars and its temperature simultaneously rises, the AI not only detects the anomaly, but also immediately identifies a potential blockage in the return valve. Additionally, AI provides valuable historical context, indicating that this condition has occurred 4 times previously on that same or similar assets. It can even estimate resolution time based on previous experience, for example, 17-minute procedure to resolve. The benefits of integrating AI are clear and tangible. Incident reaction time is drastically reduced, enabling early intervention. Major failures are prevented by identifying problems in their early stages. And, most importantly, knowledge is activated in a timely and accurate manner, transforming information into intelligent actions. One of the great advantages of this integration is that you don't have to start from scratch. The key to maximizing value lies in seamless integration with the systems your plant or facility already uses. This ensures a smooth transition and leverages past technological investments. The intelligent system acts as a central hub, orchestrating communication and information flow between all interconnected systems. It doesn't replace your SCADA or CMMS, it enhances them, adding a layer of intelligence and proactivity that didn't exist before. Common integrations provide specific and complementary contributions. The SCADA system, for example, provides real-time process variables, alarms, and events. In return, it receives direct operational recommendations from the intelligence system, enhancing its monitoring capabilities. The CMMS provides historical data on maintenance, scheduled tasks, and spare parts management. The intelligent system, in turn, receives this context for deeper analysis and enhanced diagnostics. The asset's history informs future action. The ERP, or Enterprise Resource Planning System, provides information on maintenance cycles, staff availability, and costs. The intelligent system uses this data to prioritize actions and optimize resource allocation, ensuring efficient interventions. Finally, IoT platforms provide raw sensor data, the foundation of all information. The intelligent system takes this raw data and transforms it into explained and activated intelligence, giving it meaning and purpose. It's the transformation of noise into action. Integration with existing systems exponentially multiplies the value of smart data sheets. It creates an information ecosystem where nothing is lost, where every piece of information contributes to a more complete understanding and more informed decision-making. It's the synergy of technology at the service of efficiency. To illustrate the real impact of this methodology, let's look at some practical cases that demonstrate how active knowledge transforms operations. These concrete examples highlight the potential for prevention and improved efficiency. In a solar plant, a sensor detects abnormal overheating in one of the inverters. This is a critical situation, as an overheated inverter can shut down, disrupting power generation and causing economic losses. Early detection is crucial. Immediately, the inverter's smart data sheet is activated. Based on previous experience and contextual data, the system suggests a quick air filter cleaning procedure, indicating that the most likely cause is dust accumulation due to a recent haze. The solution is specific and straightforward. The operator, guided by the precise recommendation, acts in just 5 minutes. The filter is cleaned, and the inverter temperature returns to normal levels. The intervention is quick, effective, and prevents a major failure. The direct result of this proactive action is that the inverter trip is avoided. Power production is not affected, and the plant continues to operate at full capacity. This is a clear example of how timely knowledge prevents losses and ensures continuity. In a food factory, the SCADA system detects an abnormal increase in humidity in the compressor room. Excessive humidity in this area can compromise the pneumatic system, vital to many plant operations, and cause costly failures. When activated, the smart data sheet suggests checking the seal on the compressor room door. This recommendation is based on documented experience, where a recent storm had caused a similar leak. The system learns from its own history. Thanks to this early warning and precise recommendation, the maintenance team can act quickly. The door is inspected and sealed, preventing further moisture from entering and affecting the equipment. The intervention is preventive and targeted. The result is the avoidance of a critical failure in the pneumatic system, which would have halted part of the production and generated significant repair costs. The stored and documented knowledge becomes a preventive measure when it is connected to the operational reality of the facility. These cases demonstrate that the combination of real-time data, intelligent data sheets, and AI's ability to contextualize information enables proactive management and a significant reduction in downtime and operating costs. We've taken a path that transforms knowledge management in the industry. The first fundamental step is capturing that knowledge, the accumulated experience of its engineers and technicians, and its structures in an accessible format. It is the foundation of the entire installation system. The second crucial step is to convert this captured knowledge into reusable and dynamic data sheets. These data sheets are not just documents. They are intelligence modules that can be activated and adapted to different situations. They are the bridge between theory and practice. But the real transformation, the qualitative leap that truly impacts your plant or facility, is the connection of this structured knowledge with operational reality in real time. It's when sensor data, SCADA alarms, and artificial intelligence come together to activate knowledge at the right moment. This new paradigm takes us beyond simply knowing what to do. Now, we not only know the right course of action, but also when and why we should take it. This clarity and precision allow for proactive action, anticipating problems before they become costly failures. Because now you don't just know what to do, you know when to do it, you know why, and most importantly, you can act before it's too late. This ability to anticipate is the true added value, the true competitive advantage in today's industrial environment. In the next video, we'll delve into the fascinating world of multi-agent systems and collaborative AI. We'll discover how different specialized AIs can collaborate with each other and with humans, creating an even more powerful ecosystem for optimizing your operations.